Okay, so again, we're finding the average. We're told that 4 even consecutive integers have an average of 53. Find those even integers. So we sum them up and divide by 4. Now, what do we want to do to get rid of that 4? How do I get rid of that 4? And it makes sense to get rid of the 4 right away.
Multiply both sides by 4.
Multiply both sides by 4, right? We know algebraically that's division. Opposite of division is multiplication. So let's multiply both sides by 4. Okay? This 4 cancels with this 4. That's why we're doing it. So we're left with just this expression right here equals whatever 53 times 4 is, which is 212. By the way, mental math. Let's pause for a second because I notice some of you either go to calculators or freeze up. Mental math is very easy if you think about it a certain way. How did you do that, Mike?
4 times 3
Is,
12.
and then
Take the 2, 4 times 5 is 20, so that goes 1 there, so 2.
yeah, so break it up. Think of this as 4 times 50. 4 times 50 is 200, isn't it? And 4 times 3 is 12. So this is 212. Okay, be able to do mental math, please. I'll let you use calculators, but I expect you to be able to do certain things. How many n's do we have? 4 of them. Okay, and then we have a total of 12 additional values. 2 plus 4 plus 6 is 12. Subtract the 12 from both sides. That's convenient, isn't it? And divide by 4. N is 50. Okay, n is 50. So the 4 consecutive even integers are 50. What else?
52.
52. Paul, what's next?
54.
54. And then finally, everybody?
56.
56. Okay, make sure we make the statement at the end, please. Okay, the integers are 50, 52, 54, and 56. Now, Luca, explain why you can do this in your head without any of the math in the beginning. How could I have figured out those were the answers just by knowing that the average was 53?
Well, the average, so basically, what you're asking if I can do math.
No, but why did we not really need the... I saw your eye light up in the beginning, so I thought you picked up on the answer right away.
Oh, no,
How could you do this if you just... Remember the original question was the average of 4 even integers is 53. Determine those integers. How can you do it without even having any math?
Oh, no, I just did it differently.
Okay.
Simplify the top and then divide everything by 4.
Cal, how would you do it in your head beforehand though? I thought I saw you, that's why I picked on you. Sorry, go ahead.
If you get the range from 56 and 50, you get 6, and you divide that by 2, you get 53.
Okay, that works. I wasn't thinking that way, but that works, right?
No, 52, 54, and then 50.
What? Where's 53? Isn't 53 right here? So if you want even integers that average out to 53, take the even integers around it. These average to 53, don't they? And then these average to 53. So it's the same idea as what you're saying, but just look at the integers aside of it. Okay? If the integers had averaged to an even number, it would not have been possible to get even integers as your answer. Think about it. These have to average out to give you an odd number, because an odd number is the middle point between them, and they're consecutive. It would not have worked if I had said the average of 4 even integers is 54. It would not have worked. There's no possible answer, actually, because your answers wouldn't make sense. It'd be like 54, and then where would the other ones go about? You'd have 52 and 56, and then you'd have the 4th integer over here that would skew the average down. It wouldn't actually work. Okay? So if you see that ahead of time, that's fine, but please show the math behind it. Okay? Please show the math that you're using. All right, let's go to another type of problem now. Let's see. All right, here's a good one. It says, the base of an isosceles triangle sits on top of a square. I'm going to draw it as I do it so you can see, okay? And then draw an isosceles triangle on top of it. So what does that look like? It looks like a house, you know? So the base of an isosceles triangle rests on top of a square. If the perimeter of the triangle is 24 inches, so this is what I would be writing down, and the perimeter of the square, and the perimeter of the overall 5-sided polygon is 36 inches. I'm going to put perimeter of it's technically a pentagon, right? So P. The perimeter of the pentagon, the overall thing is 36 inches. Determine what the perimeter of the square is. Determine what the perimeter of the square is. So you've got the perimeter of the triangle. It's not equilateral, so we can't just say 8, 8, 8. That would be an easy way to do it, right? Okay, we've got the perimeter of the whole thing is 36. Nick?
So wouldn't it just, for the square, wouldn't it just be 12 inches? Because it would be equal to 36.
No, because the perimeter of the triangle is using this side also. Then you're assuming this is 12. You're making this 6 and 6, making these all 12s. But the whole polygon is 36. The whole polygon. Not just the 4 or the 3 sides or anything. It's a little tougher than it looks. Okay? Let's use some statements here. Algebra. Let's label some stuff. So what do I know? Give me some information. Luca.
Triangle with 2 sides that are not the base are the same.
Good, so call them
X.
X. Works for me. All right, agreed? Everybody so far, are we okay? X, those are both the same. The base is not the same, so we don't put X there. A square, though, has the same sides, doesn't it? So we'll call those Y. You see how already we're starting to use let statements. We're using geometric let statements. You don't have to write it out, okay? You don't have to write let X equal and let Y equal because we wrote it on the diagram. I know what you're referring to now. Next, give me some sort of equations with variables and the information right.
4y plus 2x equals 36.
So close. One thing's wrong about that. Ryan said 4y, I'll write it down, plus 2x equals 36. Ryan, do you want to correct yourself? Do you know what it is? It's a small correction.
3y?
3y. This is not included, right, in the overall perimeter. Remember, this is inside of the polygon. So the perimeter of the pentagon on the outside is 2x plus y plus y plus y. This is like a bridge, okay? It's not the outside. So let's change that 4y to a 3y, but good. So that's our starting point. But can I solve this equation? It's got 2 variables. Can I solve it? I can't. So I need something else. I know something else about this. What's the first piece of information that was given in the beginning? Mike. So give me the equation.
Like adding on to that.
A new equation, yeah.
Y plus 2x equals 24.
Yes. Very good. Very good. Y plus 2x equals 24. Now, we haven't done systems of equations yet, okay? So I'm not going to hound you on this, and this probably wouldn't be something as difficult because we haven't done systems. But this is an easy system. It's a very easy system, and there's a reason it's easy. Look at the equations. This one has 2x's, so does this one, doesn't it? So what's missing in this one that's up here?
Like, wait, I can explain how to do it, but.
Oh, I said what's missing. I didn't say what the answer is. What's missing in this equation that's up here?
2y.
Yeah, there's 2 y's that aren't here, agreed? So if there's 2 y's that aren't here, and how much are they differing by? What's the difference between 36 and 24? 12. And there's 2 y's missing in the front, right? If I do this, aren't they the same equations now on the left-hand side? And I'm missing 2 y's here, and I'm missing a 12 down here. So 2y is really 12 in this case. So what is y then? 6. Y is 6 in this case. Again, let me go through it. We wouldn't do systems because we haven't done it yet, but just to think outside the box. The equations are very similar. We're missing 2 segments, and those segments each are measured as y. Well, they differ by 12. So as a result, we have that 2y is missing 12. So if 2y is equivalent to a missing 12, every y is 6. Every y is 6. And check it. Ready? 6, 6, 6, 6. That would give us the perimeter of the square of 24. If the y's are 6, that makes x 9. 9 plus 9 plus 6 makes the overall perimeter of the triangle 24. 9 and 9 is 18. 18 and 6 is 24. 6, 6, 6, 9, 9 is 36. So when you check your answer at the end, it does work. For those that have done systems of equations, how would you solve this one if I didn't do this? Let's say I had just what we had in the beginning here. How would I solve this, Luca?
Okay, so you would take the bottom equation, subtract 2x from both sides to get y equals 24 minus 2x, and then substitute the 3 times 24 minus 2x plus 2x into 36.
So you could use substitution method. There's an easier way though. I would not use that. What's the easier way this time? You could use that. More work though. You don't need to.
You can multiply a bottom equation by -1,
And then
then you can cancel out the 2x and the -2x.
you could add straight down. So let's talk about this because we're going to see it in a later chapter, but just so you're familiar with it. If you multiply the entire bottom equation by -1, this becomes negative y. This becomes a negative 2x here. This becomes a negative 24. And linear equations tell us we can add straight down. So you could literally add these equations straight down. 36 plus negative 24 is 12. 2x plus a negative 2x cancel, giving me a 0 there. 3y minus y, or plus a negative y, is 2y. And that gives me exactly what I had a moment ago, telling me that 2y is really representative of 12. So y in this problem would just be 6. Okay, I'm telling you now, I won't give you a system of equations because we haven't really studied it just yet. But the idea of setting this up, you need to be able to do this. Okay, you need to be able to say, let me put these y's here and put those x's up top and set up my equations. You have to be able to at least set it up. I would not ask you to solve a system yet because we haven't studied it yet. But you need to be able to come up with these equations that we started with. That would be like a section 1-8 problem where you were coming up with the equations, but you weren't necessarily solving them. Okay? So you have to be able to come up with the equations that you're given in the information. All right. How many people have learned terms like complement and supplement? Like supplementary angles and complementary angles? Have you? Okay, so you haven't all taken geometry. You have it next year. Next year is geometry. The year after that is pre-calculus. The year after that is calculus. So I'm not going to do a lot of stuff with supplement and complement then, just so we're not confused on the vocabulary. I was asking that because one of these questions had that word in it. All right, here we go. Ready? Triangle problem. Triangle problem. One angle of a triangle measures 11 less than twice the measure of another angle. So one angle of a triangle is 11 less than twice the measure of another angle. Okay, so one angle of a triangle measures 11 less than twice the measure of the second angle, or another angle. The second angle measures 23 less than the third angle. Find each measure. I'll repeat. One angle of a triangle measures 11 less than twice the measure of a second angle. The second angle, though, is 23 less than the third angle. So find the measure of each angle in the triangle. Doing? Drawing a triangle. You could draw equilateral ones, doesn't matter. Okay, you could draw isosceles, it doesn't matter. Okay, the problem doesn't say anything about what it is, so we don't know yet. All right, the first sentence. Can somebody tell me algebraically what I should do when it says one angle of a triangle measures 11 less than twice the measure of a second angle? Will?
You can form an equation, so it would be 2 variable minus 11.
Yes, very good. So if this is x, this is 2 times that variable minus 11. Well done, Will. Again, it says one angle is 11 less than twice the measure of the second angle. So we'll call this angle 1. We'll call this angle 2, and this is thus angle 3. Okay, it might help you on your tests or on your quizzes to label the angles with numbers or letters. Okay? So again, one angle, this angle, is 11 less than, I should use the pointer so you can see it later, is 11 less than twice the other angle. Okay, the other angle. Now, we're told that the other angle is 23 less than the third angle. So this angle right here, the other angle, or the second angle, is 23 less than this angle. So what should I put over here? Be careful, go ahead, Ryan.
X minus 23. X plus 23.
Yeah. And that's the tough part, because you hear less than, so you want to think minus, right? But this one is 23 less than this one. So either you'd have to make this x minus 23 and make this x, but then it would change this, wouldn't it? So if you're calling this x, and you know it's 23 less than something else, that means that other thing is 23 more than in the original. Again, if Ben has $23 more than Niall in his... That's not Ben at all. That's Ben. That's why. Yeah. See, sorry, Charles. If Charles... I'm learning, I promise. I'll know. If Charles has $23 more in his pocket than Niall does right now, that means that Niall has 23 less than Charles. So you could say those interchangeably, so we have to consider that in the problem. Again, we were told that the angle 2 is 23 less than angle 3. But I can't just tack on a minus 23 to angle 2 because it would affect angle 1. So I have to write it differently, and I have to say angle 3 is just 23 more than angle 2. Okay? That was the idea of inequalities. Remember when I said you could say that 3 is greater than 2, or 2 is less than 3? You can write those or say those backwards. That's what's happening here. A value could be 23 bigger than something, or that something could be 23 less than it. You could say it backwards. Okay? So if you ever make something x, and you write another angle as a function of x, you can't just change that x. You can't tack on a minus 23 and call this x suddenly. It doesn't work. Okay? Because then you have to alter that. So instead, since this is 23 less, we just add 23 to this one and say, all right, well now this is 23 more than that one. Okay? What's the final step here? What's the final step we have to do? We've set up our statements. What do we have to do to round off the whole problem? We have to come up with something so we can solve for x, right? So what does that something look like, Niall?
You write the three angles out equaling to 180.
The what of the angles, Niall?
The measure of the angles.
It's not the word you want to use. What are you doing to those angles? You're what? What's the term? I want you to use your words. That's why I keep doing this. You did it the other day, remember? What was the term I used? I gave you a symbol like this, Niall, and I said it means something. Remember?
Is the sum of?
Yeah, very good. Good job. Nice. The sum of the angles, right? The sum of the angles. So I was telling Niall this the other day. He asked me a question. This symbol here means the sum. So the sum of the angles is equal to 180. Okay, you don't have to write that. You could just write it out. So you could just write this. Okay? And then solve for x. I'm not going to waste the time solving for x. You guys can do that part. That's easy. Combine like terms, divide through. Do you want another night to study for the quiz and we have it tomorrow to start the period? Would that be useful? All right, so let's do a few more then. Because we only have about 20 minutes left and I'd have to give you the quiz right now to finish. So let's do a few more word problems today, and then we'll start tomorrow's class with the quiz, and then we'll continue with section 2-1 tomorrow. Okay? All right. That works for me. Let's see. All right, one truck has a capacity 4 tons greater than another truck. One truck has a capacity that's 4 tons greater than another truck. If the other truck, the smaller truck, makes 5 trips, and the larger truck makes 7 trips, together they can transport 112 tons of gravel. So again, one truck has a capacity that's 4 tons greater than the other, if the smaller truck takes 5 trips and the larger truck takes 7 trips, and together they transport 112 tons of gravel, find the capacity of each truck. That the small truck takes 5 trips, the large truck makes 7 trips, and together all of those trips move 112 tons of gravel. And we want to find the capacity of each truck. Okay, so I need some sort of a starting statement to compare these two trucks.
Let X equal the smaller truck.
Okay? Does it matter? What else could you have said, Kelly?
Let X equal the bigger truck.
Yep. Okay, either way is fine. And then you'd have to change your second let statement based on the first one. So if the smaller truck is X, the bigger one's going to be X plus something. Agreed? If the bigger truck were X, the smaller truck would have been X minus something. So it does not matter which way you approach the problem. It matters that you see the relative amount of each of those trucks. So what was it, 4 tons more? Is that right? All right. And I should put capacity. It's not just the smaller truck, right? Larger truck capacity. Good. So far, good. Now, we're told that the large truck takes 7 trips and the small truck takes 5 trips. And at the end of the day, after these 12 trips, they've moved 112 tons of gravel. We want to find how much each of them can move on one trip or hold for one trip. So how do I write an equation? How do I write an equation for something like this? Again, the small truck takes 5 trips, the large truck takes 7 trips. Charles?
So you could do, since the small one takes 5 times x, and then 7 plus 7 times x plus 4.
And how many tons does that equal together, Charles?
112.
Very good. Okay, that's all this one is. And let's talk about this for a second. If I can hold literally in my arms, hypothetically, say 20 pounds, after 20 pounds, I'm just tired. Not true, but say hypothetically. Okay, and I moved over, and I dropped a 20-pound brick off, and I came back, and I picked another one up, and I moved over and dropped another 20-pound brick. If I made 10 trips, I moved 200 pounds eventually, right? 20 pounds every trip. That's what the multiplication gives me. So think logically about what's happening. Every time the small truck moves, it moves 5 trips, but it has a certain capacity. The large truck moves 7 times with a larger capacity, totaling 112 tons of gravel. Are we good on this problem? Can I stop at these points and we can go to the next one? Is that all right? Can we all solve this? Distribute the 7, combine like terms, solve for x, and then write out the small and large truck capacity. All right. Let me find another one. How about one of the ones with the distance rate? One of those? With the trains and stuff? All right. Go to a new page. Following. A train traveling at 40 miles an hour leaves Anson City at 9 a.m. So I can literally represent all those words like this. Anson City at 9 a.m. and is traveling at 40 miles per hour. Okay? Next, it says at 11 a.m., another train leaves Anson City on a parallel track, meaning running next to it, at 11 a.m. And it travels at the same direction of the original train, but at 80 miles per hour. At what time does the passenger train catch up to the other train? Here's one of the catch-up problems, where somebody starts a race and the person starts later, and they run faster. There's more than one way There's more than one way to solve this problem. Okay, so I'm open to some suggestions. Mike, do you want to start us off with something?
Going is half daily, so would it take like half the amount of time
But we don't know the time it takes. We're just knowing, all we know right now is that eventually they're going to be equal to each other. But we don't actually know the time. It doesn't say when they're going to pass each other, right? We know the time difference is 2 hours, that lag in the beginning. That's good to know. We can figure out how much of a head start the person got. That's one thing we can think about. Luca?
Wait, you remember the equation we charged?
Or just some starting point for this, yeah.
You should think that the second trade is going to be faster.
Okay?
It will
It'll eventually catch up.
By the time the second train starts, the first train has already gone 80 miles.
That's the really important part right there. By the time the second train has started, the first train already went 80 miles. Okay, so now we've got this gap of 80 miles. And you got that because of distance equals rate times time. A rate of 40 miles per hour for 2 hours gives me a distance of 80 miles. Okay, again, from 9 a.m. to 11 a.m., that first train has already gotten a head start at 40 miles an hour, so it's at an 80 mile mark. So now let's put the first train here at 11 a.m. and the second train here at 11 a.m. But again, this train is traveling at 80 miles per hour, whereas this train is traveling at 40 miles per hour. Now, here's an interesting way to approach this problem. And it's maybe a different way that I explained the other day. This might be useful. How much ground does the faster train gain every hour? How much ground does the faster train gain every hour?
40 miles.
40 miles. How do you know that?
Per hour.
Yeah. See, that's the common mistake. You just use the smaller number. You happen to be right, but that's not the reason. If I change the numbers to 50 and 30, the answer would not be 30. How much does it gain on the other train every hour? Right.
40 because 40 is half the 80.
Not because it's half.
But because,
What's the word you want to use? Not half.
I know, but
Because 50, what would it be if it was, what's the word? The difference. Think about it, ready? Two people are traveling. One at 40 miles an hour, one at 100 miles an hour. Forget the problem for a second. The other's 100, so we don't have a misconception with the doubling thing. If I'm going at 40 miles an hour, after an hour I've gone 40 miles. If you're going at 100 miles an hour, after an hour you've gone 100 miles. So you've gained 60 miles on me, right? Now, if you're behind where I was, you're catching up, and you're gaining those every hour. So in this problem, the faster train is covering a gap of 40 miles, or closing the gap, like this, ready? Here's the trains. Closing the gap, closing the gap, closing the gap. Okay, now it's closed the gap after an hour. Instead of a gap of 80 miles originally, after 1 hour it's closed the gap by 40 miles. So how many hours will it take to close the gap of 80 miles? 2 hours. Again, the difference in the velocities or the rates is the gap closing rate. Every hour, the gap gets closed by another 40 miles. And if this were something like, I don't know, say we're 50 and 30, it would be closing the gap by 20 miles every hour. If the gap had been 300 miles, okay, and the one train that was lagging, but it was faster than this train by 30 miles an hour, and there was a gap of 300 miles, how many hours would it take to gain or to cover that gap? Again, if this train was traveling 30 miles an hour faster than this one, and there was a 300-mile gap between them to start, every hour it gains 30 miles because it's traveling 30 miles an hour faster. So how many hours would it take to cover or close the gap?
Plus 30.
300 miles and 30 miles every hour it's gaining. So how many hours?
300 minus 30.
Not minus.
Like about 100 or 300?
So what 300 divided by
Yeah.
30, so 10, 100. Be careful.
No,
10
sorry,
hours.
I didn't know if it was 100 miles.
Oh, sorry, yeah, 300-mile gap, yeah. So 300 miles, every hour, this train is traveling faster by 30 miles an hour. So right after 1 hour, instead of the gap being 300, now it's 270. Now it's 240. Now it's 210, 180, 150, 120, 90, 60, 30, and now caught up. So every single hour it's gaining 30 miles more. So to cover a gap of 300 miles, it takes, as Kelly said, 10 hours to do that. How can I represent that mathematically? Here's what you could do. Watch. You could say the gap in this problem is 80 miles. The difference in the rates is 40 miles per hour. So the time it would take would be D equals RT, but R is really R1 minus R2, the change in the R values. Okay, this is not the speed of one of the trains, this is the difference between the speeds in the two trains. Okay, I hate the fact that it was 80 and 40, because 80 minus 40 is also 40. But this number here that I just circled is the difference in the rates of the trains. The faster one is gaining every hour by 40 miles per hour. So let's say, even if it were something like this, if it were like 90, right, and this one were 50, it would still be a difference of 40, right? So every hour it would still be gaining by 40 miles per hour. So this is the equation you could use. You could say, well, the gap is big D, that's 80 miles. The difference in rates is 40 miles per hour. Divide by 40, after 2 hours, the train will catch up. All right, let's try another one. Ooh, this is a good one. I like this problem. Okay. You know what? It's inequalities. We haven't done inequalities yet. I'm going to pause because that one's an inequality. We'll do that once we get to section 2.1 and 2.2. Let's see. Here's a really tough one. Something makes you think though. Let's go through this. So this book, remember, was written in the 70s. So it's going to reference a tape cassette, like an old cassette. Okay. So a tape cassette contains 13 tracks. They call them musical compositions. I'm going to say tracks. Okay. Contains 13 songs or tracks. Of the 13 songs, 8 of them last for the same length of time. So of the 13 songs, 8 of them have the same time, and the other 5 each last a minute longer than the other 8. Again, 8 of them all run for, like, say, 4 minutes, and the other 5 all run for, say, 5 minutes or 1 minute more. Okay, so 8 of them at the same time length, the other 5 all 1 minute more than the other 8. If there are 15 seconds between each track, if there are 15 seconds in between each track, and the total tape is 73 minutes, how long is each track? This is a really good problem. I like this. And the reason I like it is because there is a common misconception that I pick up on right away. Okay, so let's talk about this problem. So I want you to visualize. Let me put a new slide up if I can. What's happening? I've got a song, and then a gap. And then a song, and then a gap. And then a song, and then a gap. You all see what I'm saying? Okay? And this occurs how many times? 13 times. But after that last song, is there a gap? So how many gaps are there actually? 12. So be careful. Again, if there are 13 songs, that means there's a 15-second pause period between each song. So there's only 12 of those pause periods. Okay, not 13. That's the common misconception right away. So we know that 8 of these are a certain length of time. 5 of them are a minute more. There's 15-second gaps 12 times and a total of 73 minutes. Let statements. Let statements. Let statements. What do we got for let statements? Paul, what do you want to call X this time? Which one? One of the 8 tracks or one of the 5 tracks? It doesn't matter.
Place one of the tracks.
All right. So the length of the 8 tracks that are the same. So Paul, if those are the length of the 8 tracks, and the other 5 are all a minute longer, right? How would I write that for the next one?
X plus 1.
Good. Each of them is a minute longer. So since x is a length in minutes, we put that there. We say this is the length of 5 of the tracks. All right, so I could just add those together, 8x and 5 of these, and give me the total length. But something would be wrong if I did that, right? What do I have to also include?
Well, you have to include like the 15-second gap.
And how would you do it? Would you call it
Well,
15 seconds, or would you do something else, Kelly?
0.15.
Not 0.15. 15 seconds is how much of a minute?
A quarter.
So not
Oh,
0.15.
0.5, sorry.
There you go. So each gap is 15 seconds. 15 seconds is a quarter of a minute, right? Look at the clock. It's a quarter. So each gap is 0.25 minutes. So be careful. That's another common mistake. People put 0.15. Okay, but now you remember it. So each of the gaps is 0.25 minutes. So I want somebody else to give me the equation I would use here. I want to get the equation. Nina, what do you got for the equation?
8x plus 5
Slow. 8x because there's 8 of those songs at x length.
plus 5 times the quantity of x plus 1
Because there's 5 songs that are all a minute longer than those 8 songs. Keep going.
plus a quarter of 12.
Plus 12 times a quarter. Explain that part, Nina.
Because there are 12 gaps, and each gap is 15 seconds long.
Yes. 12 gaps at a quarter a minute per gap. And the entire album is 73 minutes long. Okay? So 8 songs plus the length of the 5 songs plus the 12 gaps in between at a quarter a minute per gap gives you 73 minutes. Okay? And then you solve for x. Tonight, practice. You know what I'll do? I'm going to just scan these 2 pages here for more practice problems if you want to try more. Okay? Some of the problems we did just today. Alright? The last one on the page, or the last 2 are inequalities. So if you choose those, it might be a little tough, but you're welcome to. For a little challenge. I haven't done those yet.